This is part 1 of our lesson on solving exponential equations. So there are multiple ways that you can solve exponential equations, and we are going to talk about 2 methods today. So the first method is where you try to write things as powers of the same base and then compare their exponents, and the other method is to use logs. So for the first question we have here, I have 5 to the power of 2x plus 8 times 25 to the power of 6x divided by 125 to the power of x plus 1, and that needs to equal 625 to the power of x minus 4. So when I look at this question, something that jumps out to me is the bases. I have a base of 5, 25, 125, and 625. And I recognize that all of those numbers are powers of 5. So your power sheet is actually very helpful here when you're trying to do these questions, if you're trying to write them as powers of the same base. So the first thing I'm going to do is take 5, 25, 125, and 625 and write them all as powers of the same base. And in this case, it's going to be a base of 5. So the first one is going to be fine. I'm going to leave that as 5 to the power of 2x plus 8. But the second one, 25, is 5 squared. So I'm going to say this is times 5 squared to the power of 6x. 125 is 5 to the power of 3. So this is 5 to the power of 3, and then to the x plus 1. And if you're not sure where I'm getting these from, your power sheet is very helpful at showing you all the different powers of 5. And then 625 is 5 to the power of 4. And then that is to the power of x minus 4. So once I have everything written as a power with the same base, I can start using some exponent laws. So that's why we try to write them as powers of the same base, because then I can use exponent laws to help me simplify these expressions a little bit. So first thing I'm going to do is deal with these brackets and the exponents on the outside. So the 5 to the power of 2x plus 8 is going to stay as is. But the 5 to the 2 to the 6x, I multiply those exponents to get 5 to the power of 12x. And then 5 to the power of 3 to the power of x plus 1, I'm going to multiply 3 times x plus 1. So I get 5 to the power of 3 times x is 3x. And then 3 times 1 is 3. On the other side, 5 to the power of 4 to the power of x minus 4, I am going to multiply those. So 4 times x is 4x. And 4 times negative 4 is negative 16. Now on the left-hand side, the right-hand side, there is just one power. But on the left-hand side, I have 3 different powers here, 2 that are being multiplied and then 1 that's being divided. So I can use some exponent laws to simplify the left-hand side. So in the numerator, when you multiply 2 powers with the same base, you can add their exponents. So 2x plus 8 plus 12x, I'm going to put like terms together. 12x plus 2x is 14x. And then the 8 is the only constant, so it's just plus 8. And then in the denominator, I have 5 to the power of 3x plus 3. And that still equals 5 to the power of 4x. Take away 16. All right, from here, I'm still working on the left-hand side. I have some division, so I am going to divide these 2 powers. When you divide powers with the same base, you leave the base the same and subtract the exponents. So I'm going to do like parts together. 14x take away 3x is 11x, and 8 take away 3 is 5. And that still equals 5 to the power of 4x minus 16. So at this point, I notice when I look at this that I have the same base, 5, to 2 different exponents. But if 5 to the power of something equals 5 to the power of something, these 2 exponents have to be the same thing, right? Otherwise, they wouldn't be equal. So I'm going to, can't get the lid off my marker here. I'm going to say that since the bases are the same, my exponents should also be the same to make these two equal. So that means that 11x plus 5 should equal 4x take away 16. And then from here, I just have a linear equation that I should be able to solve. I'm going to start by taking all of my x's to one side. I have more x's on the left, so I'm going to take away 4x from each side. 11x take away 4x is 7x. So 7x plus 5 equals negative 16. And then I'm going to add 5 to each side. So I have 7x equals negative 16 plus 5 is negative 11. And then to finish this off, I'm going to divide both sides by 7. And I'm just about out of space. So I'm going to say that x equals negative 11 over 7. Now that will give me a decimal that would have to be rounded, and I did not notice in the question any instructions about rounding, so I'm assuming I need to leave an exact answer. So just as a quick recap, we took our powers. I recognized that 5, 25, 125, and 625 are all powers of 5, so I wrote each of them as a power of 5. I used exponent laws to simplify those exponents, and then I did some multiplication with exponent laws. I did division with my exponent laws, and then once I had it down to a single power on each side that had the same base, I knew that the two exponents would have to be equal to each other to make that equal. So I just set those two equal to each other and then solved. All right, so you can join me in the next video for the second part of this lesson.